today, me group and I will take turns to present to you about an innovative concept brought to you by using a thermal sensor. We're from School of Engineering, UOW Malaysia. My group consists of myself, Yogita Gantluri, Wayne Ang, Wong Ze En, and Wayne Liu. Before we begin, let me give you a brief background. So heatstroke is a condition that's defined due to the body overheating. It's defined as any time the body's temperature is over 40 degrees Celsius. If heat stroke is not treated promptly, it can lead to fatalities and sometimes even mortality. Now, why are we choosing to go about this way? Well, we've realized through research that babies actually have developed their body temperature actually rises at a much quicker rate compared to adults, about 3 to 5 times more. And in a year, from the last few years, there has been a rise in their mortality rate, oftentimes due to them receiving heat stroke, and a majority of this is contributed due to babies being in cars. Now that leads us to the question, what's causing this to happen in the first place? For that, I'll pass it to my teammate Wayne Ang.
Moving on to why are children being left in a car, and these are the contributing factors. 52% of the cases are being forgotten, 21% knowingly left their child in the car, 25% are gain access, and 2% are unknown. Moving on to the objectives, the main objectives are design and develop a thermal sensor to measure ambient temperature inside a vehicle, improve current vehicle temperature monitoring system, and lower incidence of heat stroke related child fatalities in cars. Our concept in a nutshell is to measure the ambient temperature in the car, and we want to measure the temperature in the car once the temperature inside the car rises above 38 degrees, and it will send an alert to the relevant personnel.
Thank you, Wayne Ng. I'm Anne, and I'll be talking about the working principle of our thermal sensor. Our sensor uses a Wheatstone bridge, where the thermistor is connected in series with a reference resistor and 2 fixed resistors. When the thermistor experiences a change in resistance, the voltage difference is produced across the output. The potential difference between the Wheatstone bridge is then amplified with a differential amplifier, and the output voltage of the amplifier will be proportional to the change in resistance of the thermistor. For our simulating model, we're using 2 constant blocks, one representing 0 degrees Celsius in Kelvin and another in 38 degrees Celsius, which is the measured temperature. The temperature of the blocks are summed and sent to the input of the controlled temperature source block, and the output of the block is connected to the thermistor. The changes in temperature will cause a change in the resistance of the thermistor, producing an output voltage across the Wheatstone bridge, which will be amplified by the differential amplifier. The output voltage should reflect the changes in temperature. The temperature sensor is also connected to the input and the output of the controlled temperature source block, which will be used as the reference for our results. Now I'll pass it to Wayne Liu to talk about the results that we have obtained. Thank you.
Alright, so looking from the results that we obtained for our simulation, first of all, I would like to tell you that there are 2 lines displayed in the results. So first of all, the blue color line is the reference temperature. So it's basically like a value of a temperature which we used as a reference point to determine the reliability and accuracy of our temperature monitoring system. And the actual results that is measured, or like the actual measured temperature, is represented by the yellow color line or the yellow color waveform. So we conducted 2 simulations. The first simulation, we set the reference temperature to 38 degrees Celsius, and then we began measuring the temperature of the environment. And from the results that we obtained, when the reference temperature was set to 38 degrees Celsius or 311.1 Kelvin, the measured temperature was approximately 310.1 Kelvin. So judging from the difference between the reference temperature and the actual measured temperature, I dare say that the difference between both of them are relatively small, indicating that this is a pretty reliable and accurate temperature monitoring. Take a step further to determine whether it's as reliable as we think it might be. We set the reference temperature to 40 degrees Celsius, or in other words, 313.1 Kelvin. So after we conducted the simulation, the measured temperature was approximately 310.5 Kelvin. So here the difference between the measured temperature and the reference temperature is around 2.6 Kelvin. So I still think it's relatively small. In other words, I think it's actually still a pretty reliable and accurate temperature monitoring system. Now, in summary, we have taken an approach to develop a temperature monitoring system using a differential amplifier as well as a Wheatstone bridge circuit. So our objective here is to address any issues, diseases and conditions associated with heat stroke arising in children, especially when they are accidentally locked in vehicles. Now, overall, I think based on the results that we obtained and the design of our circuit, I think we are making a pretty decent progress in developing a more innovative temperature monitoring system. And that's pretty much it from us. Thank you very much.